Okay. Let's start from question number 50. Use the following information to answer the next three exercises. A Lake Tahoe Community College instructor is interested in the mean number of days Lake Tahoe Community College math students are absent from the class during a quarter. What is the population she is interested in? Okay.
Students absent.
Student absent, and so which will be the answer, like either A, B, C, D?
Right. C.
C says all Lake Tahoe students, community students in her class. Yes, because they're not specifying anything about English, Urdu, or any maths or anything. Okay.
Wait, wanted to be math? Because it does math, college math students.
Lake Tahoe Community College interprets interested in mean number of days. Lake Tahoe Community. Yes, maths. It should be maths. It should be D. Option D.
So the following. This would be data.
Consider the following. X is the number of days of Lake Tahoe Community College math student is absent. No. Remember, I told you X is equal to and Y is equal to will be.
In this case, X is an example of a statistic.
Variable. Whenever it's something X is equal to or Y is equal to, like a variable is used, it would be variable, not
Okay.
statistic. Okay. Okay, come to the next one, 52.
The instructor sample produces a mean number of days absent of 3.5 days. This value is an example of statistic
Instruction
or
sample
data.
produces the mean number of days absent of 3.5 days. The value is okay. Yes, statistics is good answer.
And why won't it be data?
Sorry, instructor sample produces the mean number of days absent of 3.5 days. So it is just a statistic from how many days are the people absent, not the number, the data given like yes or no or the resultant given. Okay.
Okay.
For the following exercises, identify the type of data that would be used to describe a response. Quantitative discrete, we learned the definitions of quantitative discrete, quantitative continuous, and qualitative yesterday. Okay. So number of tickets sold to a concert.
Discrete.
Very good. Percentage of body fat.
Continuous.
Continuous. Favorite basketball baseball
Qualitative.
team. Yes.
Qualitative.
Qualitative. Time in line to buy groceries. Why I think we have already done this. Time is
I think
always
so.
continuous.
I think we have done this.
Yes, number of students, we have done this. You should move on. Yes, we have done 64 also.
Yeah, we have done it. 65 as well.
Okay, this is type of sampling, which is something different. We haven't learned this. We have done till like 65 questions, and this is the much data we have done. We didn't learn frequency tables, and relative frequencies. Okay. We learned yesterday about relative frequency and how to calculate the relative frequency. Yes, but we didn't do any questions related to the relative frequency. Okay. So 50 part-time students were asked how many courses they were
We
out.
did this.
We did 80. We did
Yeah, and
81.
81. Mm-hmm.
We did 81.
And yeah.
Okay. Okay, just keep on writing on your note somewhere that we have done these questions. So we couldn't repeat them. Okay, we need to do 82, I think.
Yeah.
Okay. Read the question. 19 immigrants to the US were asked how many years to the nearest year they have lived in the US. The data are the following. So this is a data frequency, relative frequency, cumulative frequency. So this all table is already given. Now what are they asking? Fix the errors in table 1.35. There are some errors here. Also explain how someone might have arrived at the incorrect numbers. Okay, what are the errors? Tell me.
Person.
2 by, what is the total? Find the total of the frequency because first step we have to find total. 2 plus 3 is 5. 5 plus 1 is 6. 6 plus 3 is 7, 8, 9. 9 plus 2 is 10, 11. 11 plus 2 is 12, 13, 14, 15, 16, 17. So the total is 17, but they're using 19. So what is the error? The sum of the frequencies is 17, but they have used
19.
they used 19. Okay, so this is the error. Okay, explain what is wrong with the statement 47% of the people surveyed have lived in the US for 5 years. 47 people surveyed. So for 5 years, there are no 47 people surveyed.
What function of field survey?
Because it would be 3 by 17 and there will be another number, not 0.47. So it should be 3 divided by 17, which will give you 0.17. So it should be 17% of the people surveyed, which will give you the correct answer. What fraction of the people surveyed have lived in the US 5 or 7 years? So for 5 years, it's 3 over 17, and 7 years, it's going to be 2 over 17. So for 5 or 7 years, it's going to be 3 over 17 plus 2 over 17, right? Which fraction of the people
Follows.
surveyed have lived in the US at most 12 years? So yesterday I told you something about at most.
3 or below.
At most 12 years. At most 12
Ah,
years means this is the, okay, I'm going to erase.
12 or below it.
So we are at most 12 years. So means maximum is 12 years. All minimum are also included. So we are going to add them all. But use 17. Okay, add them all. It would be, this is part, we are doing part E. So it could be 2 by 17 plus 3 by 17 plus 1 by 17 plus 2, 3, 1, 3, 2, 2, 3 by 17 plus 2 by 17 plus 2 by 17 plus 2 by 17. At most means all the numbers including 12 and before that, not after that.
Mm-hmm. Give me a second.
So it's easy, if you will add them all, you will get 15 by 17. Okay. What fraction
Yeah.
of the people surveyed have lived in the US fewer than 12 years? Fewer than 12 years means you're not going to add this one. You will add till here. So it means you will get 13 by 17. You will subtract 2. What fraction of the people surveyed have lived in the US from 5 to 20 years? 5 to 20 years. This wall, you will add them all. 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 by 17. Next question. Question number 83. How much time does it take to travel to work? Table shows the mean commute time by state of workers at least 16 years old who are not working at home. So this is the mean time they travel to go to their work. Okay. So what is the question? Find the mean travel time. Okay, so how to find the mean? Mean is add them all and divide them by total. So what is the total? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 from here and 1, 2, 3, 4, 5. So it means the total is 50. So you have to add all of this data and then divide by total. You will get the mean time. Okay. So how to find the mean? Add them all and then divide by total.
Uh,
So when you will add all of these points, you can add it later. 1173.1 you will get. When you will divide it by 50, you will get 23.462 and this is the mean time. Just remember, whenever you have to find mean, just add all of the items and then divide by the total number of items. Okay. Now we will do this one. Forbes magazine published data on the best small firms in 2012. These were firms which had been publicly traded for the last year. We have a stock price of $5 per share. Okay. So the age is given, frequency is given. How to find the relative and the cumulative relative frequency? You are going to tell me now. How to find the relative?
3 divided by the total.
Okay. What is total? Total is 3, add
60.
11, add 13, add 16, add 10, add 6, add 1. So the total is 60. Are you getting the total of the frequency 60?
15 plus 10. Yeah.
Okay. So the relative is 3 by 16. The relative is 3 by 60. Okay. Find the relative in the decimals because you also have to
0.05.
0.05.
05.
Okay, next.
That one. 0.18.
0.18. Okay, next.
33.
Sorry.
1833.
1833 like this. Can you write it
Yeah.
on the board?
Yeah, that's correct. Yeah, I can.
Fill in the
I don't think I
blanks.
can write.
You can't navigate. Can you
No,
annotate?
because you're sharing your screen, so I can't. I can just watch. I can't touch it.
Okay. Okay, you can tell me.
0.2166.
0.2166.
0.2666. 0.1666. 0.1. 0.0166. Now add them. 0.05.
Are you calculating next?
Yeah. I'm getting 0.9985. No, the sum I got.
The total?
Yeah.
Okay.
Wait. No, I'm sorry. Do I have to add relative frequency?
Yes, the first one is 0.05. The next one will be 0.1833. Add 0.05. So you will get 0.1833 add 0.05. It would be 0.2333.
I added all, I got 0.9985.
No. First of all, you have to find the cumulative relative frequency. It would be 0.2333 like this. Then add them and I write here like this.
Okay.
Now add both of them and the answer will be here.
Will be 0.4499.
0.4499. Good. Next.
0.7159.
Okay, next.
0.8825.
Next.
0.9825. 0.9991.
Good. Now, what is the frequency for CEO ages between 54 and 65? So 54 and 65. 54 and 65. So what is the frequency for CEO that age between 54 and 65?
Right. 32.
How did you get?
I added them.
But you're not going to tell the total age. What is the frequency for CEO that age between 54 and 65? So 54 it can be either 13, 16, 10 or 6. So we can add and divide by 4 to get the average age. What percentage of CEOs are 65 years or older? 65 or
Wait,
older are 6 plus 1, 7.
could you explain A again?
What is the frequency for CEO ages between 54 and 65? Yes, you can just add them. 54 and 65. Just add them. Okay.
Okay.
What percentage of CEOs are 65 years or older? So for percentage, we're going to go here. It's 98% or 99%. 68 years or older. Okay. What is the relative frequency of ages under 50? Under 50 is this one. So relative frequency of ages under 50 is 0.18 or less than that. Okay, what is cumulative relative frequency of CEOs and younger than 55? Younger than 55 is this one, this one. So cumulative relative frequency would be 0.71 or less than that. Which graph shows the relative frequency and which shows the cumulative relative frequency? Okay. So this is moving on. Okay. So cumulative is okay. So I'm not erasing this so that 0.05 is this is the relative one, right?
Mm-hmm.
0.05, then 0.1833, then 0.2 that is a bit above from 0. So this is the relative frequency and this is cumulative relative frequency. Which graph shows the relative and cumulative relative? So A is showing the relative frequency according to the data and B is showing the cumulative relative frequency according to the data.
Okay.
Use the following information to answer the next two exercises. Contain data on hurricanes that have made direct hits on the US between 1851 and 2004. Okay, so the category is 1, 2, 3, number of direct hits, relative frequency, and cumulative relative frequency. Just we have to find the last one, cumulative relative frequency, add this and this, you will get this. No, you have to find more. The table is ongoing. Okay. So let's complete the table first. What will come over here? It would be 0.2601 and
0.9231.
very good, 0.9231. So the next table is on the next page. So how will you get the relative frequency over here?
Divide by total.
What is the total?
18 divided by 273,
Okay.
which would be 0.0659.
Okay, 0.065, good. Okay, there is another way to find. The sum of all the relative frequencies is equal to what?
1.
1. This is another way to find. Okay. Okay, the next one is we have completed the table. What is the relative frequency of direct hits that were categorized 4 hurricanes? So 4 hurricanes, what is the relative frequency? 0.065. The answer is option B, right? You just confirm.
Yeah.
What is the relative frequency of direct hits that were at most a category of 3 storms? What is the meaning of at most? At
Going
most
up and
means
up.
maximum it was 3 storms. So what is the relative frequency of direct hits that were at most a category of 3 storms?
Um,
3 storms. What is the
we'll
relative?
add the number of direct hits.
Yes.
We'll add the relative frequency or the
They're asking
number of
about
direct hits.
they're asking about relative frequencies.
Okay. Give me a second. It would be 0.9231.
So option B is the correct answer.
Yeah.
So in this way, in this form of the MCQs, even you can get the questions in the exam.
Mm-hmm.
This is in the form of the multiple choice questions. The data is given and you just need to know that what is going on. Okay. So this is everything together. Okay. Now let's come back to the notes and let's see where did we stop last time. Okay, we have to start from symmetry and skewness this time. Now we are going to learn a new definition and it is about what is symmetry and what is skewness. A distribution is said to be symmetric if its center divides it into two approximate minor images. So if the center of the image is dividing it into two minor images which are approximate and kind of equal, then that is called symmetric. What is symmetric? Our distribution is said to be symmetric if its center divides it into approximate mirror images. Mirror images means that it must approximately equal. It's not 100% equal, but it's approximately equal on both sides from the center.
Mm-hmm.
So if it's such a event happens, then it is called symmetric. Okay, symmetric and skewness. Our distribution is said to be skewed to the right. If the right side of the histogram, the larger half of the data values extend much further out than the left side. So if the right side is more than the left side, then it is called skewed to the right. The definition of skewed to the left is if it is symmetric to the left side, then it is called skewed to the left. Okay. So what
So
is
it's
symmetric?
rising.
Yes?
I mean, skewed means like,
Skewed means moving to any one side, not on the center.
okay, this one is a left
This one
skewed,
is
right?
right. This one is right.
How is this right?
Because the histogram has moved to the right side of the equation.
I mean, isn't the right side on the opposite side? Yeah, over there.
This is the right side.
Yeah,
Okay.
I mean, by my hands, that's right and that's left. I mean, I can't hear you. Your mic.
Sorry,
I couldn't hear you.
I couldn't.
Nothing. Were you speaking before? Because I couldn't hear you.
No, I'm just speaking now.
Okay.
It should be right side and it should be left side. Anyways, whatever the right side is, if the histogram is larger on the right side, so it's right skewed on the right side, and if it is larger on the left side, so it's skewed on the left side.
Mm-hmm.
Let's move to the some more questions to clarify this. Okay. So, okay, and if the histogram is displayed vertically, we must be careful interpreting the data, because if the histogram is displayed vertically, we can consider this as the left side, but when we will move it like this, so we will get to know that is it symmetric to the right or symmetric to the left. Twenty-six. Okay. So stem and leaf plot. Do you have any idea about stem and leaf plot?
I've heard about it, but no.
You listen it for the first time.
Yeah.
So this is the most easy thing I'm going to tell you. And because now we're going to learn about the plots of different things. So let's do it with the example. And the word stem and leaf, what does it suggest? Stem and leaf plots are used for the same reasons as a histogram. Numbers are considered to be consist of a stem and a leaf. The leaf consists only one digit, the last one, and the stem consists of everything else. Not that the leaves are displayed in numerical order. So what happens? That a tree has stem. This is the stem of the tree. This is stem.
Yeah.
And there are so many leaves over here. Okay. So when we have a data, this is the stem and leaf plot is very simple. When we have a data, I have 36, I have 35, I have 34, I have 30, then I have 102, I have 103, I have 105, for example. Now this is very, the data is written like this, but to write it in the stem and leaf plot, every first number is going to be the stem. Every first number is going to be the
Yeah.
stem. But 1 is not the stem, 10 is the stem. Like
Mm-hmm.
the only last one is going to be the last one. The left leaf consists of only one digit, the last one. Leaf is going to be only last one. So apart from the last one, all others will be stemmed. So the I marked with the red are stems. So the stem is 3. I'm not going to write 3 again and again. I will write it only one time. And the second stem is 10. Now the one I'm going to mark with the blue one are going to be the leaves. Leaf. Because stem is only one, but leaf can be more than one, right?
Yeah.
So stem is only 3, but leaf is 6, 5, 4, 0. The stem is only 10, but leaf is 2, 3, 5. So we have stem and leaf plot in which we have a stem and we have a leaf. Now, if someone don't know these data, if I don't know this data, I have the stem and leaf plot and I want to figure out what is my data. So it would be the stem is going to go with every leaf, 36, then 35, then 34, then 30. Similarly, 102, 103, 105. So if I don't have the data, the stem is going to go with every leaf. Got it?
Yeah.
Now, for example, we have decimals. So in the form of decimals, what will happen?
Left one.
All of the numbers before the decimal will be the stem, and after the decimal will be the leaves. For example, now 5 is the stem over here. Okay. So what will be the leaves for the 5? 0, 4, 5, 6, 6, 7, 9, 9, 0, 0, no, 0, 0, 9, 9 till here. These are all the, this 5 is the stem, and I have covered 5.0, 4, 5, 6, 6, 7, 9, 9. Can you see? In leaves, if there are 6 2 times, I have to write it 2 times. If it's 5 2 times, I will write it 2 times. Why? Because then I will know that there are 2 leaves consisting of the number 6. There are 2 leaves consisting of the number 5. But in stem,
Yeah.
I need to write it only 1 time because stem is only 1. Now next stem is going to be 6. And the leaves will be 0, 0, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 6, 6, 8, 8, 9. So many leaves for the same. And the last one is 7. So for 7, it's going to be 0, 1, 2, 3, 3, 7, 7, 8. Got it?
Yeah.
This is called stem and leaf plot. Hope you understand this. Not difficult. The problem is, but we have a few stems. We can solve this problem by splitting the stems. So it's, what is the example? After 29, we have 30, okay. Splitting the stems, okay, 5, 0, 4, 5. We may also encounter a problem where we have too many stems. Okay, in this case, we trim the leaves, which involves removing one or more digits from each data value to make them less precise. Consider the following stem plot for the manual salaries of 25 teachers, rounded down to the nearest $1,000. So for 3, the teachers, the salaries of the teachers are $34, $37, $38, $40, $42, $42, things like that. What is next? Okay. Note that a histogram and a stem plot are very similar. They both display the same information, except the stem plot has the advantage of also displaying the data values. So how to make the histogram? So if I have a histogram, I'm just going to plot the data over here. I have the values 34, 37, 38. I have the values 80. So the minimum value I can take is 30. Then I can move from 40. I will make the intervals. In the histogram case, I'm going to make the intervals like this. So I know the data from 30 to 40 is still 38. So here I have 8. So I will make the diagram like this. Then I have from 40 to 50 is 49 is 40, 42 till 49
Yeah.
like this. So in the histogram, we just plot the bars and the bars are attaching one another. But in the stem plot, that is a bit different thing.
Yeah.
Like a histogram, a stem plot enables us to describe the shape of the data distribution. So because in the stem plot graph, we start from the minimum and go to the maximum. It's not like we will write 9 first and then 4 last. We will go from 3, 4, 5, 6, 7, 8, 9. So when we will go like this, we will get an idea that how the data is moving. So we know that the data is moving like this and then like this. So data is skewed to the left.
Mm-hmm.
If we can make it like this, skewed to the left. Okay, again, now this data when we make is like this, like this. So it's approximately symmetric, it's not skewed anywhere.
Mm-hmm.
Histogram also gives us the same information. Okay, now this one going like this. So it's going to be skewed to the right. Got it? It means the histogram and stem leaf plot both are giving us the same informations. Histogram also tells us about if the data is skewed to the left or right. Stem plot also gives us information if the data is skewed to the left or the right, or if it is symmetric. Consider the following back-to-back stem plot. Okay, which simultaneously displays the height distributions in inches for a sample of males and females. So what is the meaning of back-to-back stem plot? It means now I have some information for males. Uh, what is the information? And some information for females. And I have to make only one stem plot. So what I will do, I have the information for males. That is, they have the height 65, 65, 67, 70, 76, 78. I have the information for females. They have the height 16, 36, 36, 76, 76, 96, like this. Now I have to plot both the information back to back, means on this one in the same plot. So I will draw a line and I will write stem in the center. So what is stem? It can be 6. The miles per gallon waiting for 30 cars are shown below. This is the information that is given. You have to do question number 1. For each of the following data sets, create a stem plot and identify any outliers. Okay, now we have to draw a stem plot graph. Can you do it yourself?
Yeah. Do you want me to write on the paper and then send it to you?
Yes. First try write the stems and then write the leaves. Okay, let's do it. So we have stem and we have leaf. Okay. So what's going to happen? Let's mark them. It's 1.
One.
And
That'll
then
be one, and then
2.
two.
Then the next stem is going to be 3. And the next stem is going to be 4. So the stems are 1, 2, 3, 4. Now, as we get the stems, what are going to be leaves? It's going to be 9, 9, 9. Then 0, 1, 1, 5, 5,
Five.
5, 6, 6, 8, 9, like this. Then
Mm-hmm.
1, 1, 2, 2, 3, 4, 5, 6, 7, 7, 8, 8, 8. The last one is 1, 3, 3. Okay, so this is a stem leaf diagram for the first one. Can we make for the second one? It's easy, not that difficult.
Yeah, just drawing a line, just separating those numbers. I get it. I understand.
Okay, you understand. Can you do question number 3?
Yeah, for 3, we'll take the first two numbers, 24 to
Yes.
26.
So you
And the
have the
last
stem is
digit
going to
we'll
be
leave it there.
24. Then stem is going to be 26.
Yeah.
The next stem is going to be 28. It's going to be 29. Then 30, 31, 32, 35, 36,
30,
then
38,
38, 40,
40,
45,
45,
48,
48,
55,
55,
56,
60.
57, 61. So it's going to be, can you make me right here? 24, 26, 28, 29, 30, 31, 32, 35, 36, 38, 40. It's 45, 48. I'm not able to finish them. 55,
I
56.
get the idea, I understand.
Sorry?
I get the idea, I understood.
Okay. So you will be able to do it, right? You will
Yeah.
just write it 9 because 40, 24, 9. So it's
Mhm.
again 9 like this.
Yeah.
Also, will you be able to do the question number 4?
The same thing, right?
Yes, same thing.
Yeah, I'll be able.
Okay. So the next is in a survey, 40 people were asked how many times they visited a store before making a major purchase. The results are shown here. So what you have to do? Okay, for the next 3 exercises, use the data to construct a line graph. So this is what we need to do. We have to draw a line graph over here. Okay. So how it's going to work is number of stores in the number of times in store. Always write frequency on the y-axis. This is the most easy thing. When you will write frequency on the y-axis, you will write the other data on the x-axis. So it's going to be 1, 2, 3, 4, 5. So frequency is going to be, we can take the interval of 2, 4, 6, 8, 10, 12, 14, 16. Okay. So for 1, the frequency is 4. For 2, the frequency is 10. For 3, the frequency is going to be 16 at the top. 4, it's going to be 6. For 5, it's going to be 4. So this is the frequency. So this is called the line graph. Okay, always plot frequency on the y-axis and others on the x-axis. Can you do the line graph for question number 6 now?
Yeah.
Okay.
I'm gonna draw the line.
Do it on your notebook
Um,
somewhere and you can match it. So for frequencies, what will be the interval that we will be taking? Because the largest one is 22, so we have to reach 22. So we should take
yeah.
5. It would be better. Okay. So for 0, it's going to be 2. 1, it's going to be 8. 2, it's going to be 13. 3, it's going to be 22. 4, it's going to be 16 something here. 5, it's going to be 9. So you will get a shape like this. Are you getting a similar shape?
And could you go back up again? From on the fifth one.
This was 6-1, yes, for the 6-1.
No, which was the value for the fifth frequency? I mean the fifth
Fifth one is 9.
9, okay. Yep, I got the same.
Okay. So can you do this one, 7th one in your homework?
Yeah.
Take the
So,
picture of this, so you will do it in the homework.
give me a second.
It's very similar.
I'm done. Okay.
The next is, Okay. The student in Miss Ramirez.
Can we continue this different class because I have other class after this?
Sorry?
I have to be somewhere after this class.
Okay, okay. So the time is up?
Yeah,
Okay, take care. We will continue
you
it
too.
on another day, inshallah. Take
Okay,
care. Bye.
bye.